So I asked you to find the mass in kilograms of water in this tank. So if the tank is 80% full. So there's a couple of things we need to know. One is 1 milliliter is equivalent to 1 cubic centimeter. And that 1 cubic centimeter is equivalent to 1 gram, if that cubic centimeter is water. 1 gram is defined to be the mass of 1 cubic centimeter, or 1 milliliter of water. So we can find the volume of this, which will be 4 meters by 2 meters by 3 meters, otherwise known as 24 meters cubed. We need to convert that into centimeters cubed. 24 meters cubed is how many centimeters cubed? To get from meters to centimeters on the chart, our decimal point, or we have to go 2 spots to the right. Now, since this is cubed, our decimal point has to go how many spots? 6. So it starts there. We're going to have to fill in zeros. 1, 2, 3, 4, 5, 6. That's 24 million centimeters cubed. Now here's the tricky part, is only 80% full. So we could either do the 80% now and say that's only 80% of the volume, or we could get the weight of the mass of the whole thing and then use only 80% of that. Really doesn't matter which. Let's go ahead and switch this over. 24,000 cubic centimeters of water would be, or 24 million, would be 24 million grams, which would be how many kilograms? Well, from grams to kilograms, it's 3 spots to the left on the chart. So my decimal point has to move 3 places to the left. So that's 24,000 kilograms. So that would be the mass if the tank were full. We have to figure out what if the tank is 80%. So 80% is 80 out of 100. Blank out of 24,000 kilograms. 80 times 24,000 divided by 100 is 19,200 kilograms. You may come up with that? No? Okay. Makes sense. Yeah, it's one of the neat things about the metric system is, as long as you know what they are, there's actually very easy transitions from volume to capacity to mass. As long as you're dealing with water, of course, for the mass. Well, let's say we were dealing with something a little bit more dense. You know, we talked a little bit about density. You know, density was mass divided by volume. If you have something that is 80 grams and it fits into a volume of, maybe it's a little more realistic, 16 centimeters cubed, that divides out to be 5 grams per centimeter cubed. That would be the density. Whenever you see a rate like that, 5 grams per centimeter cubed, it can actually be used as a measurement equivalency. What that is saying is 5 grams is equivalent to 1 centimeter cubed. Just like saying there's 12 inches per foot. That's 12 inches is equal to 1 foot. Same type of thing. So if we have an object that we know has a density of, let's say 19 grams per cubic centimeter, and we want to find the volume, but let's say it's an awkward shaped object, but we find that its mass is 247 grams. We can find its volume from that. We can actually use what we've been doing for our measurement conversions to convert that. 247 grams over 1. And we're going to use this equivalency, the 19 grams per cubic centimeter. That means 19 grams equals 1 cubic centimeter. We use grams, cubic centimeters. 19 grams, 1 cubic centimeter. Grams divides out. This becomes 247 times 1 cubic centimeter is 247 cubic centimeters on top. 1 times 19 is 19 on the bottom. We divide that out, we get 13 cubic centimeters. 19 grams per cubic centimeter, by the way, is approximately the density of gold. So this, if you had some sort of gold figurine or whatever, you could figure out its actual volume from its mass. Well, these conversions can also be used in a little bit more complex settings as well. For example, let's say that I tell you I can throw a baseball. Can't even spell throw, but I can throw a baseball. 90 feet per second. That means standing on first base on a baseball field, I could throw it and it'd be at home plate in 1 second. Is that fast? Do you think I could throw that fast? Yeah? Well, is it fast is the big question. What are we used to seeing speeds expressed in? What units? Miles per hour. So we need to convert that into miles per hour. So we're going to write this as 90 feet over 1 second. Now we need to get rid of feet and change them into miles, and we need to get rid of seconds and change them into hours. Let's get rid of feet first. So where are feet going to go in my conversion factor here? On bottom, so they'll cancel out. We're going to miles, so miles is on top. The relationship between miles and feet is 1 mile is 5,280 feet. So the feet would cancel out. Right now we have miles on top and seconds on bottom. So the miles is good. We need to get rid of the seconds. This is a little tricky to get rid of seconds here. Where are we going to put it in the conversion factor? It's going to go on top. Why does it go on top? Because it was on bottom before. So it has to go on top so it'll cancel out. We don't have a direct relationship from seconds to hours, so I'm going to go from seconds to minutes. 1 minute is 60 seconds. Those seconds cancel out. We are now in miles per minute. So put minutes up here, hours down here. 1 hour is 60 minutes. And now the minutes cancel out, and we are in miles per hour. So I've got 90 times 1 times 60 times 60 miles is going to give us what? Is that 324,000 miles? Does that look right? 1 times 5280 times 1 times 1 hour is 5,280 hours. So of course that doesn't tell us much yet. We need to divide that out. 324,000 divided by 5280 is what? Like 61.36 miles per hour. I'd have to warm up first, but I could probably still throw 60 miles an hour. Probably only throw 4 or 5 of them before my arm starts to hurt. What we did here was converting compound units, unit rates, feet per second, miles per hour, anything that has 2 units put together to create it. One example of that is what we were doing with our density up there. We had 19 grams per cubic centimeter. We could convert that 19 grams per cubic centimeter into pounds per cubic inch. Now I said 19 grams per cubic centimeter is about the density of gold. It's actually, gold is actually 19.3 something. Anybody want to guess how many pounds per cubic inch gold is? Is a cubic inch of gold more or less than a pound? No guesses? Yes, it is more. Well, let's take a look, see what we come up with. 19 grams per cubic centimeter, we're going to write as 19 grams over 1 centimeter cubed. We've got to convert grams into pounds. If you look it up, 1 pound is 400, it's like 453.6. We're going to go 454 grams. So now we're in pounds per cubic centimeter. We need to get rid of cubic centimeters. Where are they going to go? Top or bottom? Top. Cubic centimeters on top. Cubic inches is going to go on bottom. The inch is bigger, so 1 cubic inch. Now, how many centimeters are in an inch? 2.54. So a cubic inch would be 2.54 cubed, 16.387. So now the cubic centimeters are gone, and we are in pounds per cubic inch. So on top, we've got 19 times 1 pound times 16.387 is 311.353. That's pounds. On bottom, we've got 1 times 454 times 1 cubic inch. That's 454 cubic inches. So we divide that out, that's 0.686 pounds per cubic inch. Yeah, gold is only about 0.7 pounds per cubic inch. Yeah, that's an easy one to use. Your conversion sheet, I think, has one on there. Yeah. Is it? What does it do? 453 point. Oh, 0.36. So it should have been 453 instead of 454. Okay, 0.6. Gotcha. Okay. What if I have something that is listed as 0.9 pounds per square inch? And I need to know what that is in pounds per square foot. We don't always have to change both units. Sometimes we're just looking to change one of them. So 0.9 pounds per square inch is 0.9 pounds over 1 square inch. Are we changing the pounds? No. Pounds, pounds. So it's just the square inches we're changing. They go on top because they were on bottom. 1 square foot is how many square inches? 144. Very good. Square inches cancel out. 0.9 times 144 is 129.6. Does that look right? Pounds over 1 square foot, so it's 129.6 pounds per square foot. If you got something that's listed as 120 ounces per square inch, we want to figure out what is that in pounds per square inch. We're used to seeing things in PSI, right? So it's 120 ounces over 1 square inch. Are we changing ounces? Yes, we are. So they go on bottom, so they'll cancel out. And what's going to go on top of them? Careful. The ounces are going to be changed to pounds. The relationship between pounds and ounces? One pound is 16 ounces, yes. Do we need to change the square inches? No. Square inches are staying square inches. So 120 times 1 pound is 120 pounds. Over 1 square inch times 16 is 16 square inches. We'll need to divide that out. 120 divided by 16 is 7.5 pounds per square inch. What do you think? Not so bad? You have a pump. The specs say that it can pump 4 cubic inches per second. Pumps are typically rated in CFM. What does CFM stand for? Cubic feet per minute. So we need to convert this. 4 cubic inches over 1 second. Do we need to change the cubic inches? Yes. So it's going to go top or bottom? Bottom, because they're on top. And we're changing it to cubic feet. Relationship, 1 cubic foot is 1,728 cubic inches. So that'll take care of the cubic inches. We're now in cubic feet per second. Are we changing the seconds? Yes. Where's it going to go in our conversion factor? On top, because they're on bottom now. And we're changing them to minutes. 1 minute is 60 seconds. Seconds cancel out. So 4 times 1 cubic foot times 60 is 240 cubic feet. On bottom, 1 times 1728 times 1 minute is 1,728 minutes. So it's 240 divided by 1728. 0.139 basically cubic feet per minute. That's not very good. Anybody know what a good pump is usually? Usually between 9 and 12 cubic feet per minute. Yeah. Yeah, most of your displacement pumps. Fuel pumps are way down there. I don't remember what it is for fuel pumps. It is in cubic inches per minute for a fuel pump. Yeah, most of your good water displacement pumps are between 9 and 12 cubic feet per minute. In your notes, 50 gallons per minute. Try to change that to cubic feet per minute for me quick. I'll give you. So we've got 50 gallons over 1 minute. Are we changing the gallons? Yes, we are. Gallons will go on bottom. We're changing it to feet cubed. 1 cubic foot is how many gallons? 7.5. Good. That gives us 50 gallons, or sorry, 50 cubic feet over 7.5 minutes. The gallons cancel out. We divide that out, and that's going to be, what, 6.67 cubic feet per minute. Any questions there? Okay. On the metric side of things, it's actually a little bit easier. Do you still need that for a second? On the metric side of things, time is really the only thing that's tricky for us. Now, if we have something that is, well, let's say it's listed as 40 meters per second, and I want to change that into kilometers per hour. It's 40 meters per 1 second. I have to change the meters to kilometers, but that's actually really simple. I do have to change seconds into hours. Let's do that first. Now, we had said earlier there is no direct conversion from seconds to hours. We're doing seconds to minutes, and then minutes to hours. 1 minute is 60 seconds. 1 hour is 60 minutes. You could, if you really wanted to, just say, hey, 60 times 60 is 3,600. So 1 hour is 3,600 seconds. You are allowed to combine those equivalencies to come up with it. We did it a little bit with our capacities yesterday. So anyway, this is 40 meters times 60 times 60 is 144,000 meters over 1 hour. Why didn't I convert the meters yet? Well, because that's really simple. I'm changing this then into kilometers per hour. Well, the 1 hour isn't going to change. 144,000 meters is how many kilometers? Well, to get from meters to kilometers on the chart is 3 spots to the left. That's just 144 kilometers. So 40 meters per second is 144 kilometers per hour. Is that fast? It's a little more than 60. So that's 144 kilometers over 1 hour. Let's change our kilometers to miles. 1 kilometer is, anybody know? Look on your sheet. 1 kilometer is how many miles? I usually go with 0.625, but look on your conversion sheet quick. They got listed as 1 mile is 1.61. We can use that. So 1 mile is 1.61. Kilometers cancel out. So it's 144 divided by 1.61. It's about 89.4 miles per hour. That's why I was kind of laughing, because it's almost exactly in between what you two are saying. Well, according to the Wisconsin State Patrol, it's a little fast. Okay, so let's say you have something that is listed as 0.23 kilograms per cubic centimeter. You want to know what that's going to be in grams per cubic millimeter. You put it as 0.23 grams over 1 cubic centimeter. Now, because this is metric, we do not have to use the conversion factors. We're just going to translate. Kilograms are changing to what? Grams, right? 0.23 kilograms is how many grams? From kilograms to grams, we move 3 spots to the right. So 1, 2, 3, add a 0, that's 230 grams. Cubic centimeters are being changed into cubic millimeters, millimeters cubed. You go from centimeters to millimeters is 1 spot to the right, but it's cubed, so we have to go 3 decimal points there. We're going to go 1, 2, 3, filling in the zeros. We divide that out. 230 grams divided by 1,000 cubic millimeters. 0.23 grams per millimeter cubed. That's one of the easy conversions in the metric system. Because of the way it's set up, kilograms per cubic centimeter is equivalent to grams per cubic millimeter. They won't change. What's that? I wouldn't go that far. In your packet, page 238, 57 through 64, and page 266, 55 through 62, are dealing with these conversions.